Hi, I'm Jason Link, Product Manager for LC Columns, and I'm here with Christoph Deckers, an Agilent Sample Prep Applications Engineer. We want to share a full workflow solution with you, demonstrating protein precipitation and a screen procedure for 3 opiates.
We'll start with sample preparation, which we'll take you through here. And in part 2, Jason will work with Rory Doyle. He's our mass spec application engineer, and he will demonstrate the analytical part of the process.
In this scenario, we're looking to emulate the type of work that's done in a typical forensic or drugs of abuse testing lab, or the type of work you might find being done in a pharma DMPK lab. We're interested in keeping our analysis time down, but we can't sacrifice our results. We'll walk you through the application and point out tips and advice for improving results along the way.
So, here are all the supplies we need for today's experiment. First of all, we need some tips for the pipetter. The associated pipetter, in this case, is an 8-channel pipetter. We need some methanol or ACN. We obviously need some plasma samples to analyze. We need our Captiva ND lipids well plate, the vacuum collar, and at the bottom, we need the collection plate. And finally, but not the least, we need a vacuum pump.
Now, Christoph, what would happen if we skip sample preparation?
Well, plasma is viscous and has a lot of matter which we don't need in our column. If we don't do sample prep, we'll reduce the lifespan of our column.
What about guard columns?
Well, good point, Jason. The guard column will help preserve column life and also maintain consistent chromatographic results. But when it comes to sample prep, there's more to it than that. Sample prep helps prepare your sample so you get better results by increasing our signal-to-noise ratio. It would also help to protect our mass spectrometer as we want to maintain its high sensitivity. Some part of the sample, such as the lipids, may cause problems in our MS analysis due to ion suppression. We'll talk more about this in a moment. In this case here, we're using Captiva ND lipids, which will help remove the lipids in our sample that could contribute to ion suppression. So sample preparation does 2 key things here. It first reduces the buildup of extra material that may cause your system or your sample to clog and require extra maintenance. It actually supports the work your guard column does. And secondly, it improves the accuracy of your analysis by improving the sample quality.
Okay, Christoph, let's look at an example of the interferences you mentioned.
Sure thing, Jason. For plasma, we are challenged by the presence of salts, proteins, and lipids. I'm going to show you on screen some data that illustrates how Captiva ND lipids works as compared to standard protein precipitation methods, such as Captiva ND. So on the green chromatogram, you see the nonpolar and polar phospholipids that you'll typically see in plasma. The red line shows the same analysis, but after using Captiva ND lipids. And you'll see that the lipids have been almost completely removed. That's pretty nice. If not removed, well, these lipids will stick to your column for up to 50 column volumes and come out really randomly, reducing method robustness. They can also contaminate the source of your mass spectrometer, requiring extra maintenance on your system. By using this filtration, we'll improve our results, have better robustness, and reduce instrument maintenance.
Now, Christoph, how is Captiva ND lipids different than just Captiva ND?
Well, good question, Jason. Remember that the Captiva ND lipids product contains a reverse phase sorbent that retains lipids. This is excellent for samples that have low log P values, such as the compounds we are analyzing today. However, if the compounds you are analyzing have high log P values, that is, if they're hydrophobic, they may also well be retained by Captiva ND lipids product. So you'll want to work with the standard Captiva ND well plate. Generally, we recommend ND lipids to be used with analytes that have log P values below 3.
Okay, so this is an example of just enough sample prep, right?
Yes, it is. In today's busy labs, people are looking for ways to cut analytical time and do more with less. We understand that, and we're under the same pressures ourselves. At Agilent, we talk about just enough sample prep. What that means is, we want to find the techniques and tools to help you to spend just the right amount of time for the necessary impact on your analysis.
So, what are the trade-offs?
Well, Jason, there aren't so many trade-offs these days due to the very high sensitivity of the newer instrumentation. That's why we're able to save time and do just enough sample prep. If we were not using the mass spectrometer, we might want to use solid phase extraction, such as our Bioanalytical products, and that would concentrate the analyte very well for UV analysis. However, with the mass spectrometer, we aren't going to need as much concentration in our sample. So that allows us for cleanup methods that do not concentrate as much as solid phase extraction. So here, we're going to opt for protein precipitation. And we're making our protein precipitation easy and fast with the Captiva ND well plates.
So, how much recovery will we get with this method?
You'll find that Captiva ND well plates will get you to improve absolute recoveries versus standard protein crash. Generally, it'll be about 10% higher, so you can anticipate a recovery of about 40% using Captiva ND well plates.
Okay, let's get started.
All right. For a typical analysis in a bioanalysis lab, we would need to start with whole blood and centrifuge it down to get the plasma. For our purposes today in this video, we're using plasma that we have purchased spiked with our opiate panel. For protein precipitation, we're going to use the Captiva ND well plate. More specifically, we're going to use the Captiva ND lipids format, as this will help us pull down our lipids that would cause trouble in our MS. This format is designed to be very easy to use for large sample volumes in a high throughput environment. It has some advantages over other plates because you won't get between well clogging. You'll get very consistent flow following our guidelines.
So, why are they called non-drip?
Well, easy question, I like those. That's because these well plates enable you to put the organic in first and then the plasma, so you don't get plasma precipitating into the membrane. With other well plates, you were forced to add the plasma first to avoid the organic dripping through the plate. And this was a big issue because it led to plasma precipitating into the membrane and plugging everything. So, for this analysis, we're going to take our plate and put it on the manifold nice and snug. Then, we're going to put our methanol or ACN first. Remember, in this case, we're putting ACN. That's 300 microliter here in this case. As you can see, the nice non-drip feature allows the solvent to stay in and not start dripping right away. Then, you add 100 microliter of plasma sample to each well. And then it's important that we dispense and aspirate between 3 to 5 times to ensure proper mixing. After this, we need to put our vacuum pump on at a pressure between 7 and 15 inches of mercury. As you can see, there's a good suction here. And that's it. The entire procedure is over.
So, what are the advantages of these plates versus other standard well plates?
Well, Jason, the key advantage is that you are able to add the organic in first, like I mentioned earlier. So you can use the same pipette for all 3 steps. First, adding the organic, then adding the plasma, and then aspirating. That saves a lot of hassle, especially if you're using automated sample prep in a high throughput environment.
Great. So, we're ready to go.
Yep, our sample is ready to be analyzed. So let's quickly summarize what we've discussed today. First, the trend today is to use just enough sample prep, which means less time-intensive methods are necessary when you're using more sensitive instrumentation. And secondly, Captiva ND well plates and Captiva ND lipids well plates are a very easy protein precipitation method that takes just seconds to use and improve absolute recoveries versus standard protein crash techniques. And thirdly, we saw that Captiva ND lipids products will remove lipids to reduce ion suppression in the mass spectrometer. It should be used with hydrophilic compounds or compounds with a log P below 3. And finally, we saw that Captiva non-drip well plates are convenient because you can use the same pipette tips to do all 3 easy steps.
Thanks, Christoph. Now we're ready to take our sample to the instrument for analysis.